Okay, so we're back down to where we got some actual homework problems. The first homework problems were just doing that erase the base stuff. And then it seemed to get all theoretical, lots of stuff about logs. And you might be thinking, but I don't get what's going on. Nobody ever really feels comfortable with logs. Everybody feels comfortable looking at an exponential. Anyway, all of these next few problems are just designed to get you comfortable with it. So we're going to use that when the base and the base are smooshed up against each other thing. They don't want to know if this is true. They just want to know, can I rewrite it in the other format? So the plan is I'm just going to change both of these to having like a base stuck underneath them. Do the reverse of erase the base. I'm going to stick a base right there and stick a base right there. So that now, instead of this being the problem, those are just the powers to the problem. So in other words, I just write it 3 to the log base 3 of 1/9 and 3 to the negative 2. And then I go ahead and use that when the base and the base are smooshed up against each other, they cancel out. To cancel both of those out, now I've got 1/9 equals 3 to the negative 2. So it is written in the exponential format, and then this way it kind of makes some sense to me. I know negative exponent means jump over the fraction bar. So it makes more sense this way. This, I couldn't really, it's confusing and it doesn't feel right, but this is why we keep just rewriting them into exponentials. All right, now if I have to do the second one, okay, there's no base. Well, there is a base. If you can't see it, it's invisible. That means it's a 10. So I want to shove up under these. I want to put both of these up into the exponent with a 10 up underneath them. And then over here, when the base and the base are smooshed up against each other, they cancel out. So 10,000 is equal to 10 to the 4. Yep, that's true as well. All right, let's try another one. Okay. Now I want to shove a base up underneath these, and the base I want to do is 13. And these cancel out, so 1 equals 13 to the 0. That's true as well. Anything to the 0 is 1, so that's got to be true. Now let's do it the other way. Okay, so that was rewriting logs as exponentials. Now let's rewrite some exponentials as logs. Okay, so that means I'm going to write a log on both sides of this. And the log that I need to write it's got to be the same base. So there's a 3 right there. So 3, log base 3. Okay, and that's going to take advantage of this base and that base are smooshed right up against each other, so they'll cancel out. So now I have 2 equals log base 3 of 9. And I don't really have a lot of feel for these. 3 squared equals 9, that I know. This, I'd have to think about it a long time because I don't have an intuitive feel for it. But that's all that's going on. All we're doing is figuring out how to use that little rule to rearrange stuff. It doesn't matter if you're not really feeling it at this point. We're just going to go ahead and go through how to do it. All right, I need to write a log on both sides. And the log needs to be base 4 so that it'll smoosh that out. So that cancels with that. So now it says 3 equals log base 4 of 64. Or this last one, 10 to the 6th equals 1,000,000. All right, that's log base 10. You can write the base 10 on there if you want, but you don't have to because everybody knows if it's invisible, it's a 10. And and this little 10, that cancels this with this, so it says 6 equals log base 10 of a million. You didn't have to do any x equals or anything like that. You just have to rearrange them.